So this is what we have discussed so far. What is correlation analysis, regression analysis, terminology used in regression, and regression and prediction model, confidence interval and prediction interval, and then a few case studies we have seen. And now look here, I have shown 3 scatter diagram. Now tell me, the first scatter diagram, it is what kind of relationship it is?
Positive.
Positive.
Correlation.
Not only positive, strong
Strong
positive.
positive.
Second one, strong
Strong
negative.
negative.
The third one, completely scattered.
No correlation.
That means no correlation, right? No correlation and no relation. And in order to understand with the numerical value, this is the formula for Pearson correlation coefficient. N is the number of data. X bar is the average of the X value. Y bar is the average of the Y value. Sx is the standard deviation of the X value. Sy is the standard deviation of the Y value. The individual X value, individual Y value. See here, 0 to +1, positive correlation. 0 to -1, negative correlation. Up to 0.4, it is weak correlation. 0.4 to 0.7, moderate correlation. 0.7 to 1, strong correlation. Clear? And now, this is the problem we have discussed. Calorie consumed and then weight gain. And the diagram also confirms. And this red color line is nothing but the regression line. If you want to derive this equation, you can derive it yourself. And how to derive, I have told you. And what kind of correlation it is? Is it positive or negative, strong or weak? What is your opinion?
Strong. Strong positive.
Strong and positive.
Strong.
Either you look at the graph and tell, or otherwise look at the value. Value is 0.97 R value, right? So looking at the R value, it becomes very easier. This is strong, negative. Strong positive, strong negative. And what is this?
No correlation.
No correlation.
No correlation.
You can say weak positive.
Weak correlation.
Right? Because some trend you can observe gradually increasing. This is weak positive. And this is weak negative. Weak positive, weak negative. And what is this?
No correlation.
No correlation. What is this?
This
Correlation.
curved
Curved relation.
correlation.
Correlation checks whether there is a linear relationship or not. So the first case, there is no correlation. Also, there is no relation. But in the second case, there is no correlation, but there is a parabolic relationship. Parabolic means curvilinear.
Correlation.
Parabolic means second degree equation. Right? So regression means you have to generate the mathematical equation describing the relationship. The regression equation can indicate the direction, indicate the size, as well as statistical significance. You all know statistical significance means p-value. Regression can be used as a prediction model. I have shown you how to do the prediction for X value of 1850. And in order to generate the mathematical equation, we are going to use a method called principle of least squares. So model order, regression equation, regression coefficient, and then residuals. So these are all you must know when you want to work with the regression equation. Linear order means the equation will be in this type. Y equal to mx plus. Here, how many x is involved? Only one x. This is called simple linear regression. If multiple x are involved, that will be multiple linear regression. That means ax1 plus bx2 plus c. But x is raised to the power of 1 only. There is no x square term, right? Then it is linear model. Quadratic means it's a second degree equation. Ax square plus bx plus c. This is called a quadratic model, or otherwise regression of model order 2. Cubic equation. Cubic means ax cube plus bx squared plus cx plus t. Right? If the model is linear, how many constants are involved here? Come on, please. When the model is linear, how many constants are involved?
A and B.
A and B. Only two constants.
Two constants.
under such situation, just 2 experiments are enough. 2 experiments are enough to generate the equation. So when you are doing the design of experiment, the number of experiments required depends on the number of constants that are involved in your equation. Do you all understand? How many experiments are required when your regression equation is like this?
3.
Minimum 3.
Minimum 3.
If you are studying temperature, you should set the temperature at least at 3 levels: low, medium, and high.
High.
Then only you can find out A, B, as well as C. You understand there is a connection, between the tools. And now this equation has 4 constants. And now you have to have 4 levels. 4 levels for your factor. Maybe low, medium, high, and then very high, something like that. So you have to have 4 levels to generate this kind of regression equation. See here, this is the regression equation, and regression equation is available here. And this we have discussed enough, y equal mx plus n, all those things. And this is called model summary. Can you all notice, see something here? This is called model summary. What is the R square value you are seeing here?
94.
Do you remember we also derived this, right?
94, yes. Right.
0.97, we multiplied it 2 times. R has become R square. That R square is written here. This is model summary. What is this 94 is telling? 94 is telling that
Relationship.
94% of the changes observed in the y variable are due to the changes you have made in the x variable, which means a single factor is controlling your y variable. Clear?
So can you please repeat again?
See, R square 94% means 94% of the changes observed in the y variable are due to the changes you have made in the x variable.
That means if we increase 94% of the x, then the result will be.
No, not like that. If you change the x, y will definitely change.
Yeah.
And the influence is 94%. If I change something else, instead of changing the x, I change something else. Do you think y will change?
No.
Because it is listening to 94%.
Okay.
When you are a strong influencer of your wife, I'm talking to your mother. Do you think I'll get my work done? No. If I want to get my work done, I should talk to your wife, not your mother, because you listen more to your wife and very less to your mother. Very, very less. It's less than 6%, isn't it? So
Yeah.
the influence of a factor on your y variable is reflecting in R square. That means the single root cause is the factor you are currently studying. When the R square is low, it means multiple root causes are involved. Now, so regression can indicate direction as well as size of relationship. Sign of the coefficient indicate the direction. The coefficient value represents the change you can expect in the y variable. 0.4631. What is the meaning of 0.4631? I increase the calories by
Let's say 0.46. That yeah.
Y will increase by 0.46 units.
0.46.
Whatever physical units you are following. Right? So this is what I have also explained. See here, the curve is extended. And now this is y-intercept. The x value and x line and y line are drawn. The ratio of the y value divided by x value is the slope. Nothing but your tan theta, opposite side by adjacent side. All of you have studied.
Yeah.
So you all know. So here, your y variable is this bar, this pipe, and x variable is here. I increase the x by 1 unit. Now what will happen to the y? X is initially here. I increase it by 1 unit. Now what is that you can expect for the y? Y is here now.
It will increase it.
It will increase only by
0.46.
You understand? The physical unit for x is calories. Physical unit for y is grams. It depends from case to case. So what is where from you understand this? We understand this using the regression coefficient. And graphically you see what is the regression coefficient of this equation?
Y equal to x.
What is the regression coefficient here? I
Y,
mean,
yeah, y equal to, yeah.
what is the m value here in the regression equation? Tell me how much is the m?
M into 1.
Yeah, the coefficient of x is the m, no?
Yes.
So there is no coefficient means it is 1. When m equal to 1, see here, I increase x by 1 unit. What happens to y?
Y also 0.46 increase.
Not 0.4. Y also increase by 1 unit.
1 unit, 1 unit. Yeah, correct. Yeah.
M equal to 1 means I increase x by 2, y will also increase by 2. Every increase of 1 unit will give an increase of 1 unit in y. You want to bring y from 0 to 4. Then what will you do? You will increase x from 0
Here
to
4 and here also 4.
your problem is getting solved.
Yeah.
Y is your profit. Now it is let's say y is 1 crore now profit. You want to make it 4 crore. Now, why are you getting profit 1 crore? Because x is at 1 crore. Now I increase the x to 4. Now what will happen? My profit also will become 4 crore. So I get some idea about how to get my solution. Suppose if your regression equation is in this manner. When I increase the x by 1 unit, what do you notice here? Y is increasing by? Come on, tell me. Increasing x by 1 increases by
2
units. So m equal to 2. When the line is passing through the center origin, C is 0. C is 0. When line is passing above, C will have a positive value. When the line is passing below, C will have a negative value, right? So that's how it is. Now there is another thing called residual. When you are generating the mathematical equation, see here, the blue color line is the regression line. The dots are the real experimental values. The real experimental values are red color dots, but regression equation is the blue color line. Tell me honestly, is this blue color line passes exactly through your experimental values?
No.
That means your regression equation is having an error. That error should be minimum or maximum?
Minimum.
Minimum. Then only
It will fall under the rule.
All your discussion will have a meaning. So this error is called as residual. This error is called as residual. And your goal should be residual should be low and residual should be normally distributed. Normally means it should not be crowded at any area. It should be distributed evenly throughout the equation. See here, throughout the equation there is an error, isn't it?
Yeah.
And half of the error should be above the line and half of the error should be below the line, approximately. How do I say all these things? These are all properties of normal distribution. And now what is residual? Residual is the difference between your experimental value and the fitted value. Fitted value means the blue color line. Experimental value means red color line. I mean red color point. See, consider one point. Maybe this point, 380. What is the red color value? The experimental value 380. But you have converted the 380 into 350. Then only you can draw the blue color line. Am I correct here? 380 is brought down. So,
yes.
So you consider that as 350. Now, how much is the error in your regression equation for that particular point? 30.
30.
This is called residual. The residual is positive. Sometimes the residual will be negative. If you pull the point upward, then residual will be negative, isn't it? Whether it is positive or negative, both are error. Am I correct?
Yes, yes.
And total error should be 0. Total error should be 0. 0 is impossible, but total error should be minimum. If I want the total error, what should I do? Can I sum up all the error here? For example, in this case, the error is plus 30 here, minus 30 here. When I sum the errors, what will be the net error?
0.
Does it mean there is no error in your regression?
Yes.
No.
No. Error is
Residual, you have error on the positive side, you have error on the negative side.
Yeah, it will no. It will be on the up and down, above and below. But error will be there.
Of the error,
Yes.
mathematically it is getting cancelling, but actually it is not. It doesn't mean that there is no error. I have error on both sides.
Yes.
So in order to understand the total error, I should not go with the algebraic sum. I should square them and then add them. Because positive also problem for me, negative also problem for me. So when I want to combine error of this nature, I should square the positive value I should also square the negative value and then only I should add, and then I have to take the square root. Right?
Yeah.
So the sum of the squared value of the residual should be minimum. That should be your goal. Sum of the squared value of the residual should be minimum. Then only your regression equation will speak better. This is called the principle of least square. All of you understand?
Yeah.
Fine. So a linear regression equation will have this format. How do I know my regression equation should be linear? Look at your scatter diagram. Your scatter diagram gives the clue, isn't it?
Yeah.
Similarly, if your scatter diagram is appearing like this, you should go for the quadratic equation. If your scatter diagram is appearing like this, going up, down, again going up, again down, up and down nature, that means it is cubic. Similarly, higher order trend is available. You have to refer and then go for it. But generally, if you go up to the cubic order, that itself will be a complex scenario. All of you are comfortable up to this?
Yes, sir.
Yes, sir.
Now the same problem, weight gain and calorie consumption. We fed it in Minitab. Minitab's report is generated and everything is available here. You know about everything. Now look here. There is first term in the model summary, capital S. You know what is capital S? Capital S is the capital S means standard deviation. What is deviation? Deviation is the residual.
Yeah.
So standard deviation should be low or high? Should be low. We want the residual to be low. So S is included in your model summary, and the goal is in any regression equation, S should be as small as possible. And R square, our goal should be maximum. If R square is maximum, let us say R square is more than 80%. That means you can say the root cause is single. I mean, the number of root causes, the number of factors considered are sufficient. Do you all understand what is the meaning of R square? The number of factors included in your regression model is sufficient. You don't have to worry about other factors because your R square is already 94%. This conclusion is confirmed by adjusted R square. This conclusion is confirmed by adjusted R square because the R square is a formula which is designed in such a way that it will increase if the number of factors are increased. When you include more factors in your regression, R square will increase. But sometimes what happens, you may, in order to increase the R square, people might add irrelevant factors. If you are adding irrelevant factors, what will happen? Then also R square will improve. But then, in real time, your readings, your experimental values may not align with your regression equation. In order to figure out such issues, to resolve such issues, adjusted R square is introduced. Adjusted R square, if it is close to R square, if the adjusted R square is close to R square, it is a second confirmation that all the factors included are genuine factors. All the factors included are significant factors. For example, the learning outcome, the knowledge and skill level of the participants in the black belt training program depends on the knowledge level of the trainer. Is this factor a significant factor?
Yeah.
The first factor is significant. And so the regression equation, when I generate between your knowledge level and the knowledge level of the trainer, the R square will be high. I am adding one more factor. The knowledge level of the participants depends on the gender of the trainer.
No. Irrelevant.
No. Whether the trainer is a male or a female, the impact is going to be same. And so the second factor what I considered is irrelevant. When I try to add an irrelevant factor in my study, R square only will improve, but not the adjusted R square. Do you understand? the course materials, the quality of the course material is the third factor I'm bringing. Now R square will also increase.
Yeah.
Adjusted R square will also increase. The color of the shirt the trainers are wearing, is it a significant factor?
No.
Whatever color the trainer is wearing, and that is not going to influence your learning outcome. So when I consider fourth factor as the color of the shirt, R square will improve, but adjusted R square will not improve. So which is giving a clear picture of the significance of the factor. R square or adjusted R square?
What?
Adjusted R square.
Adjusted.
So when you have 2R square, believe on the adjusted R square, not on the plain R square. Adjusted R square will give you a clarity on the purity of relationship. Right? Now predicted R square. What is predicted R square? Whether your regression equation is ready for prediction or not. Whether your regression equation is ready for prediction or not. Now 92%. That means it is ready. No more study is required. No more experimental study is required. Now the regression equation is ready for prediction. For example, you all know we have the ISRO office in Bangalore. Am I right?
Yeah.
That they have all information about the satellites and the space vehicles launched by India. Am I correct? Let's say a particular satellite. Where is the particular satellite currently? Do you think ISRO will be able to tell you give you an answer?
Yeah.
How? Is
They are
that
having
go to the space and come and tell you?
They will have everything in the system and that
Everything
launch.
appearing in the system. How everything appear in the system?
They are deprogrammed.
They have the data.
That the program has the regression equation fed in it. Right? Depending now the position of the satellite mainly depends on the time. Am I right?
Yes.
Because it is running with it is moving with a specific velocity, and the path of the satellite, any guess? Is the satellite will move in a straight line?
No.
Elliptical path?
Yes.
Circular path, elliptical path, you know everything. So the mathematical equation is derived. That mathematical equation is converted into a simulation software. The simulation software will show you the position of the satellite on your computer. All the simulation softwares work only based on a carefully developed regression equation with the predicted R square close to 100%. If the predicted R square is close to 100%, whatever you see in your computer monitor will actually happen in real time also. Do you understand? Yes or no?
Yes, yes.
If they say by 3 o'clock today afternoon, the satellite will be at that particular latitude, particular longitude, and particular altitude, yes, exactly, it will come there. Maybe more or less slight problem will be there. That's why we always have confidence interval and prediction interval. Isn't it? We'll always have confidence interval and prediction interval. So the prediction will be very accurate if the predicted R square of your regression equation is close to 100%. Anything above 80% is really a good regression equation. Is that all of you understood so far? Yes?
So can you explain again the confidence and the prediction?
The confidence interval, I'll explain. That's coming in a separate slide.
Okay.
See here also p-value comes. Whenever a p-value comes, what should be your goal? P-value should be less than 5%.
Less than 5%.
When p-value is less than 5%, you can believe in the regression equation. Look here, p-value is very low. Now another example. This is for a casting industry. This is for a casting industry. And you all know casting industry, there is a big problem. Porosity is a big problem, isn't it?
Yeah.
There'll be holes, unfilled areas, you call it, porous casting, hollow casting. So there are several factors that can influence your casting to become porous. that can influence your casting to lose the strength, required strength, and all those things, right? And so all the known factors they have controlled. All the known factors they have control, but still the problem is not fixed. All the known factors they have control, but still every time they produce the casting, every time there are rejections. Particularly these kind of porosity, it is difficult to detect. You should do ultrasonic testing, isn't it? And so many things you have to do because the holes are inside. So you have some mathematical techniques and to prevent it. So you did brainstorming, you did YY analysis, you did cause and effect matrix, and so many things you have done. And there is a strong suspect that hydrogen content, should also be optimized. We never kept an eye on the hydrogen content. So hydrogen content, is varying, in a wider range, and that is why porosity is often coming and going. Do you understand? Some experts are telling, when you are actually, pouring the molten metal can have the hydrogen present in it, and the amount of hydrogen that is present in your molten metal should also be optimized to prevent porosity. This is the expert opinion now. Now you want to verify. So you did an experimentation. Hydrogen content is purposely varied and porosity levels are measured. Now you are plotting the regression equation. Now the regression equation is like this, and it is confirmed by the p-value. And now look at the model summary. How much is the R square?
10.04.
What is this telling you? What is this telling you?
40%.
Close to 40%.
Close to 40%.
So the hydrogen content has a role in making your castings porous. But what is its influence in terms of percentage?
40%.
Close to 40%.
Close to 40%.
But I already told you, more than the R square, you should look at the adjusted R square. So how much is the adjusted R square?
33.9. 34.
So 34% is the influence your hydrogen content has got on the porosity. So if you really wanted to solve the porosity problem from the current level, you should not only optimize hydrogen content, but also some other factors are there that you have to study again. All of you understand? Your brainstorming was not, sufficient. Your experts have thrown light only on the hydrogen content, but which can help you only solve 33% of the current problem. If you really wanted to solve the porosity issue, in addition to the hydrogen content, you must add additional factors. Okay. So one more example. Can we all see one more example?
Yes, sir.
Shall we all see one more
Yes.
example?
Yes, yes.
Yes, sir.
Yes.